0.36 here that's produced. They want to know how many moles of this. So if we take this value, we bring it up. When we take it up out of this BCA table, you're going to divide. So 0.36 divided by 2 is 0.18. And then when we come down and go back into the table, we multiply. So I need to take 0.18, multiply by 3, and I get 0.54. So 0.54 moles of H2 would be produced. And he does that with dimensional analysis, but I think it's much faster with these BCA tables. All right, the next one is grams to grams. Here they're giving you, they want to produce 75 grams of H2. 75 grams of H2, then if we take 75 and divide by 2, which is the molar mass of H2, we are going to end up with 37.5 moles of H2 that we produced. If we take that up into the cloud, again, when we go up, we divide by the coefficient. So 37.5 divided by 3, that is going to give us 12.5. And then they wanted to know how many grams of aluminum are required. So we're going to take that 12.5. We're going to come down. When we come down, we multiply. So 12.5 times 2 is 25 moles. And then they wanted to know that how many grams that is. So we're going to take the 25 moles. We're going to multiply that by the molar mass of aluminum, which is 27 grams per mole. Your moles will cancel, and your final amount is going to be 675 grams of aluminum. Again, this, if you're keeping with sig figs, this would give you, you would have 2 sig figs here. So technically it would be 680. If you do it my way, with his way, the way he rounded, he ended up with 670, but it's close enough as long as you're showing your work to people. And these BCA tables are an absolutely acceptable way of showing your work. The next one, they're telling you that we've got 4.25 grams of aluminum that we're starting out with, and they want to know how many mils of 5 molar hydrochloric would be needed for that. So the first thing we need to do is take our 4.25 grams of aluminum. We need to divide that by 27, which is the molar mass of aluminum. And when we do that, we get 0.157 moles of aluminum. I'm going to take that up into the cloud then. And when I take that up into here, I'm going to divide by 2. And then I'm going to multiply that by 6 to bring it back down here, which gives me 0.47 moles of HCl. So if I have 0.47 moles of HCl and I have 5 molar hydrochloric, remember that your molar value equals moles over liters. So if we have 5 molar equals this, we're going to be solving for our liter amount here, which we're going to call X. So multiply both sides by X, that will give us 5X, and then divide by both sides by 5. So 0.47 divided by 5 equals the liter value, the volume that we're looking for in liters. And when we do that, we end up with 0.094 liters of HCl, which then would give us 94 and I guess it would be 2 sig figs, so 94 milliliters of HCl would be required for that reaction. All right, again, same equation here. We're just doing it with the ideal gas law this time. So we're starting out with 35 grams of aluminum. We've got excess HCl. They want to know what the volume of the H2 is going to be. So if I take 35 grams of aluminum, divide by 27, which is the molar mass of aluminum, I'm going to end up with 0.648 moles of aluminum. I am then going to take that up into the cloud. So 6.48 divided by 2, then multiply it by 3. I end up with 1.94 moles of H2. But they didn't want to know how many moles, they wanted to know how many liters. So then, since this is not at ideal conditions, we need, or standard conditions, excuse me, standard conditions, we don't have a ATM of 1, we don't have a temperature of 273, then we have to put it into our PV equals nRT formula. Okay, we're solving for volume. So volume is going to equal nRT over P. All right, so my moles I calculated up here were 1.94. I'm going to multiply that by the R value that we use when we have ATM, which is 0.08206, then times the temperature in Kelvin, 345, divided by our pressure, which is 1.12. So when I calculate that out, my volume here ends up being, I'm going to have to pull up my calculator for this one. Oh, no, I do have it down here. 49 liters of H2. So 49 liters H2 would be our calculated volume. All right. So the next one is trying to determine, I believe this is our last one, is trying to determine limiting and theoretical yield. So how much we're going to make of this item. So here we're starting out with 125 grams of aluminum. So I need to calculate 125 grams. I need to turn that into moles. So I'm going to divide this by 27. When I divide it by 27, I end up with 1.3. I'm sorry, that's the wrong one. When I divide it by 27, I end up with 4.63 moles. And then this one, they gave us molarity and they gave us liters. So if we know that molarity equals moles over liters, if we want to figure out mole amounts, we're going to multiply our molarity times our liters. So if we take 2.5 times 3.2, that's going to give us 8 moles of HCl contained in that material. All right, now they haven't told us that we have one in excess, so we have to figure out which one is which. So we have to create 2 different clouds. So I'm going to take my 4.63 and I'm going to take it up into the cloud. I'm going to divide it by 2 to get it into the cloud, and I get 2.32 for one of my clouds. So here's my first cloud. Then this guy I'm going to take up. 8 divided by 6 is going to give me 1.3 in this cloud. And you pick whichever cloud is the smallest and you work your problems with that. And whichever cloud belongs to, whichever cloud is the smallest, whatever that belongs to is your limiting reactant. So our limiting reactant here is HCl. So our first question here was, what was the limiting reactant? It's HCl. Okay. Then they want to know what is the theoretical yield of our H2. And if we take our cloud and we multiply it by 3, we end up with 3.9 moles here. But they wanted to know that in grams. So 3.9, we're going to multiply that by the molar mass for H2, which is 2. And so we end up with 7.8 grams of H2 produced. He continued on and asked how much aluminum. He didn't have it written up here, but he went on in his video and asked how much aluminum we would need to use. So if we take the 1.3 and we multiply that by 2, we're going to find that that's going to be 2.6 moles of aluminum that we're going to need to use. So 2.6 times 27, which is the molar mass off the periodic table for aluminum, that ends up with 70.2 grams of aluminum used. Another common thing that they will ask us about that he didn't do in his video is they will ask you how much of this is left over. And so a lot of times you'll end up having to do a part of the video where you have to, or not part of a video, but part of a problem where you have to figure that out. So we would have 2.03 left over. So 2.03 moles of aluminum excess. And if you wanted to find that out in grams, you'd multiply that by 27. And let's see what that is. 27 times 2.03. So 54.81. So 54.81 0.8 grams of aluminum excess. And that's a real common question that they'll ask you as well as a follow-up. So, all right, so go back and finish watching his stuff on titration now.